Alright, so today we're doing things in terms of y. Now this is the same problem from our last video, so this should be a little bit easier for us. We already know that the answer is the integral from 0 to 2 of our top function, which is 2x, this line, minus our bottom function, which is x squared, or this parabola right here. And it's equal to 4/3, evaluated from 0 to 2. So what if we want this in terms of y? Because that's what your Cal2 teacher is going to ask you. So to put this in terms of y, all you do is you take these equations and you put them in terms of y. So you solve for x basically. So y is equal to x squared. You solve for x by taking the square root of y is equal to x. It's now in terms of y. It's not that hard, it's not that complicated, but your Cal2 teacher probably won't explain it all that well. I know mine didn't. So we're going to have this function, which is y is equal to 2x, and all you do is divide it by 2. So y divided by 2 is equal to x. And that's it. Now your equations are in terms of y. So how do you want to think about this? Well, I told you to think about taking the area between curves as the top function minus the bottom function. But now these are in terms of y, so what you have to do is you have to flip or turn this graph around like this to see which is the top and which is the bottom, because now y, it's in terms of y, so y is your base. So I'm going to draw it over here just for a little frame of reference. This is our base, it's now y, and this is x. And all I'm doing is just flipping the graph like that. So it'll be the same thing, but turned this way. So this is y, this is 0. This is our square root of y, or x squared. And this is y divided by 2, or 2x is equal to y. So we're going to write this as y is equal to x, and the square root of y is equal to x. Now, we can still, now that it's in like this, we have everything in the way that we want it, or we can visualize it a lot better. We can see that all we have to do is subtract the top, or take the top and subtract the bottom, just as we did earlier. So we can start writing our integral. And our top function is obviously the square root of y, so square root of y, minus the bottom function, which is y divided by 2. Y divided by 2. And remember that this this top function is all this area right here. It's this entire area. And that the bottom function is this area, the area we don't want. So all we're doing is subtracting it out. And that's how you want to think about it. And our bounds are going to go from 0, forgot a dy, to a. Now we don't know a. We knew it over here in terms of x, and it was equal to 2. Let me show you. It was equal to 2. So how are we going to put this in terms of a? Well, to find 2, we just solved the equations. We set them equal to each other. So we can set these equal to each other, or we can do this a faster way. Since we already know it's 2, we can say that, well, x is equal to 2. What is y going to be equal to? So you can just put it into these equations. So when x is equal to 2, I'm just going to use y is equal to x squared. 2 squared is 4. So that's where they converge at. This point on the graph is 4. So we now know that a is equal to 4. Now say you're not given that, what you would have to do is set these new y functions equal to each other. Or you can set the two x equations equal to each other. It doesn't really matter, you'll get the same answer. But for this case, it's just a little bit easier. So we just plugged it in. We plugged in this 2 because at x equals 2, we know they converge. So we want to find the y value, we just plug it in. Okay, so that y is equal to 4. We're now evaluating from 0 to 4. So let's rewrite it as 0 to 4, square root of y minus y divided by 2 dy. And we're ready to take the integral. So when you take an integral of a square root, naturally you want to rewrite it as an exponent. So 0 to 4 of y raised to the 1/2 minus y divided by 2 dy. And this is just a simple integral. You're going to want to add 1 to the top and divide by what you get. So y is equal to 3/2 divided by 3/2 minus y is equal to 2 divided by, it was already divided by 2, and we're going to divide it by this 2 again, so we get 4. Remember, we want to invert this because it's a fraction. So it'll be 3 and 2. 3 over 2 minus y squared, 4. Evaluated from 0 to 4. So let's do this on a new clean sheet of paper so we can see all the action. So we know that our integral was y to the 3/2 over 2 times 2 over 3 minus y squared over 4. Evaluated from 0 to 4. So we know that it's going to be 0, and so since they both have things in them, or things that we plug into, we're just going to ignore that because we know it's going to equal 0. So when you put it in terms of y instead of x, you plug it into the y instead of the x. It's not trivial, it's not rocket science, that's just what you do. So let's do this. 2 4 to the 3/2 over 3 minus 4 squared over 4. And we know what this is. It's obviously 16 divided by 4, so that's going to give us 4. So we have minus 4. And now this looks a little bit tricky. You don't really know what to do. But we see this divided by 2, so we know that's going to be a square root. So square root of 4. And that 3 just carries over to become a cubed, times 2 divided by 3. And we know the square root of 4 is equal to 2, and we know that 2 cubed is equal to 8. So we're left with 2 times 8 divided by 3 minus 4. So 2 times 8, that's 16 thirds minus 4. 4 times 3 to cat it, or what was I doing? 4, yeah. If we're going to put this in thirds, it's going to be 4 times 3, which is 12 over 3. And we get our final answer, which was the same answer we got in terms of x, 4 thirds. So basically what you want to remember when doing this in terms of y is to invert the functions, solve for x, like so, over here, and then flip the graph so you can see it better. But if you don't need to flip the graph and you already know which one's the top and which one's the bottom, then just go ahead. But that's basically how you would do it in terms of y. And that's it.